Hello, I blabbed for a while here, so if you want to jump to installation, go to 5 minutes, and if you want to go to how to use the tool, go to 8 minutes and 20 seconds. All right, hey, check this out. Huh, just kind of some nice oh, wait, what? Oh, wait, what? Yes, Nathan has made a tool that lets you track a face. I am very, very excited, and it's still, it's still a little bit funky because this is just kind of where the technology's at. But finally, we can do stuff like this, and I've already used it for a bunch of stuff, and knowing that I can do it means I'm rethinking, all of this stuff that I'm going to be doing in the future. Here, I'm going to displace this a little bit, give it a transparent material. And if I go into texture paint here and create a new base color with an alpha of 0, yes, I can combine it with the transparent in the shader editor and create kind of little holographic, imagine I did this, but it was like actually like good stuff, like a little techie Iron Man things or whatever, and it's like, oh, that's rad. And look at this, it's not just tracking the head, it's actually deforming like with the face. It is very cool. Okay, so first things first, Nathan Vagdahl is actually a little reluctant to release this tool because when Nathan releases a tool, he wants it to be clean and polished and easy to use and idiot-proof. And because this tool is actually just a Python script that like talks to the actual brains made by Google, it's reliant on other libraries and stuff, and there's a lot of room for idiocy to sneak in. But I said if people find it a fraction as useful as I found it over the past week, then they probably won't mind doing a little bit of work to get it installed. Also, this walkthrough is just for Windows. We just don't have access to a Mac, although I think the process should be the same. You might have to Google how to install an environment variable. And if you're on Linux, all of this should be very easy for you, I assume. That said, it's actually not that hard to install. I'll show you in a minute. That said, if it turns out things go wrong on your end and it doesn't install easily, we can't provide tech support for, there's just too many variables. There's across all of the different systems and all the different libraries and things that could go wrong. I'll walk you through it as good as I could, and hopefully, people can help down in the comments, but anyways, let's go back to the beginning, because it has long been like a curiosity or maybe even a peeve of mine that for the past decade I've been able to point a phone at my face and in real time add dog ears and nose and like put my face on my friend's face and all of that, like in real time. But if I want to do that in a VFX pipeline, I have to literally track all of the pixels and try to do like, or a Mocha track or something, and it's like, why don't we have that technology? And so I did a post on Twitter saying, hey, how come I can't just do this as part of a regular VFX workflow? How come I have to shoot it on a phone? And because it's Twitter, 90% of the responses were like, hey, I think there's an app on a phone that can do that. And I was like, thank you very much. But a few people had a few pointers. And the reason I wanted to be able to like track heads is because for the past year, I've been planning this scene where there'd be like a giant floating holographic head. And at one point, Brian David Gilbert sent me a message on Twitter, and I was like, Brian, you slip into my DMs, I'm gonna ask you to be a giant floating holographic head. And he said, hey, that's great. But I didn't want to have to ask him to film himself on a phone or do anything like that. And so I just filmed the entire scene with his regular webcam, assuming that I'd be able to figure out how to do all of the tracking on my end after the fact. And I was pretty sure I'd shot myself in the foot because I asked all of like the smartest people I knew, people who knew machine learning, people who knew weird alternative VFX workflows. I went to every heavy hitter I could think of, and everybody's like, I feel like it should be possible, I just don't know how. But the one useful lead I got from a bunch of folks over on the Twitter thread was OpenCV, which I don't even really know what it is. It's like Google's tracking machine learning initiative or something like that. And so I went over to Nathan and I was like, Nathan, can you please look at this? It says if you know Python, you can probably work your way around it. Can you see if this is easy or hard? And he's like, it's probably hard. And he messaged me the next day being like, never mind, it was easy. And actually, in the interest of accuracy, Nathan wanted me to point out that it wasn't OpenCV that was useful to us, it was Google's MediaPipe. So, because the tools already exist. Like, face tracking is a very known thing, but what didn't exist was a way to get that information into Blender. And also, 98% of all the results I was finding talking about this stuff was really excited about the fact that it was real time, to the point where I was like, can you do it not real time? Like, what if you you've already shot the movie and you want to do the tracking after the fact? So that's what Nathan's tool does, is it just integrates between, you know, Google's face tracking, whatever, media pipe system, and Blender. But because of that, we have no control over what Google's doing. We're using some of their libraries and things, and if they ever, like, change them up or discontinue them, like, we can't guarantee the tool will keep going. It's kind of reliant on them keeping up their end, so we can't make any promises. So with that said, let me show you how to install it. We're going to make sure we have up-to-date Python, use Python to install 3 libraries automatically, and set up an environment variable. All very easy stuff. Okay, and I'm here on Caitlin's laptop because I want to do completely from scratch install. And so we have to install a few things here, but if we install Python first, Python will actually help us install the other ones really easily. So the first thing you want to do is install Python for your system, and this is important. So just go to Python downloads, and let's download the latest version for Windows or whatever system you're on. Okay, click on this. All right, and it's really important you check this right here. This will let you access the Python from the command prompt. And you'll see we're installing a bunch of different stuff here, including pip. And pip is the little utility, the useful Python utility. I think it's called like preferred installer program. They'll let you install the other stuff just by typing it into a command prompt. We'll get to that soon, but here, let's click install. And the first time I tried to do all this, it actually didn't work because I'd installed a 32-bit version of Python because I think I was trying to like mess around with Arduinos and they prefer 32-bit or something. But because that was already there, it messed up the whole deal. So yeah, it's possible you'll have to go through and uninstall previous versions of Python. Probably not, but that kind of is what we're talking about. Like, there can just be one weird thing you've done on your computer that can throw off this whole process, and we might not be able to help you. All right, I'm gonna open a command prompt. I'm just gonna run cmd, or you can type this into the start bar or whatever, and here we go. And now we should just be able to use Python to install these other libraries that we need. So as far as I understand it, OpenCV, Google trained with machine learning, trained a lot of different algorithms to be able to identify like hands and faces and objects and different things like that. And MediaPipe, which we're also going to be installing, takes those algorithms and actually implements them into like, okay, you can identify a face, turn it into like a point cloud of, you know, identifiable points. And what Nathan's script does is it takes those points and it turns it into an actual 3D face in Blender. And so that's kind of my understanding of what we're doing here. I don't totally know how it works. I'm just very happy that it does. So what we're going to do first is just look at this and be like, okay, let's pip install numpy, which I think is actually short for like number Python. And look at that, it just does it. Great, let's do the next one. Pip install OpenCV Python. And you can even just copy and paste these straight into the terminal. It's super easy. And the last one, MediaPipe. And this is where I had problems before because I had the wrong version of Python, but it looks like this is working right off the bat, so. All right, we've got our libraries installed, and the final thing you gotta do is create a new environmental variable, which is really easy. Just type environment variable into the start menu and click on this. Go down to environment variables, create a new one, and just paste this into here, and the variable value itself will be Python. Okay. And that's it, it's all set up. Or at least now we're ready to download the tool from the Eat the Future GitHub repository. Which is where we've got a bunch of Nathan's tools going on. This will be public. Oh, what's this? Compify. Private. Blender add-on for easier, better compositing in 3D space. We should release that one. But yeah, go to Face Track here and go code, download zip, and unzip it somewhere. And there we go. Everything is set up. Now using it is actually really straightforward. It is through the command prompt, which if you're like me, you hear that and you're like, oh no, but it's stupid simple. So this is the Python script you want. I'm gonna open a command prompt here, and use the script. I'm just going to drag 3 things into the command prompt. The first one is the script itself. I'm going to make sure there's 1 space after it. Next, I'm just going to track in the video I want to track. Just drag and drop here. There we go. 1 more space. And the third thing you put in is the destination where you want it to put the final tracked face. And I always seem to put in this stuff wrong, so I'm actually just going to drag in the video again, but change it from MOV to MDD, which is the file type, and now if I hit enter, opens up a new thing, it's analyzing all the frames, and it's done. And you can see it just popped up right here. And we'll go back into the folder you downloaded, and we have Face Mesh and Face Mesh Perspective. Let's open up Face Mesh. And this is a file Nathan's put together to try to make it as easy as possible. So here we're gonna load in that MDD file we just made, right there. And you can see that makes the face nice and small. I'm also going to load in the footage right there. And here, if we go into like material preview, You can see it perfectly matches. Oh wait, no it doesn't, because we have to increase the number of frames because Blender's kind of weird that way. And here I'm also going to open up a little timeline down here so we can scrub around. And here we go. We've got Ryan Gosling in Blade Runner just having an absolutely horrible time. Look at him. It's poor guy. So there's a lot of stuff to say about this. First off, I mean, this is just very cool. This completely saved my butt. I was able to make that video of Brian David Gilbert into a hologram in like literally a minute, and then I just added some texture stuff on top to make it kind of feel, you know, a little more hologrammy. It's also orthographic, which is pretty interesting, which means if you set up a camera here and you change it to orthographic and move it to, let's see, this side of the face, and set the scale to 1, and set the background image to the same video right there, and give it the right number of frames too, and line up the camera with your face. There we go. It all lines up. Personally, I love that I can put a bunch of different clips just like all into one sequence and process a whole scene at once. You'll notice at each edit, it takes a couple frames to kind of lock back in on his face. So if you have a couple frames of buffer, that can help. But yeah, just putting one frame of black in between each shot means it's not trying to like morph all the faces into one. It'll just kind of like start over. I don't know, that was really handy for me. And Nathan also added an empty in the back that's averaging out these 3 empties. There might be a better way of doing this, but this is if you want to try to add goggles or something like that. This is a good way to get started with that. Again, you'll notice it's not exactly perfect. There is a bit of wiggle, and especially if it's like glasses trying to sit on a face, like that's a pretty complex interaction, so you might have to finagle it, and sometimes it might not even work. But yeah, something else that's weird, you'll notice it looks fairly steady in these wide shots, and it actually isn't until we cut to a close-up that everything starts to really feel like it's jittering. And I think that's because of the machine learning training process. I think they actually feed it a bunch of low-res stuff. In fact, part of the process it uses for analyzing your footage is to identify where the face is, down-res it to like 300 by 300 pixels, and then it does the analysis on that reduced size. And so funnily enough, you can actually get a better result by blurring your footage before you dump it through the script, which is just counterintuitive, but it's kind of, it just smooths everything out. Here we'll drag in the blurred version, we'll drag it in again, but change it to MDD. It does its thing, and there we go. And in Blender, if you want to swap it out, it's as easy as just opening this up and going to the blurred version. And you'll see, yeah, okay, yeah, that's a bit smoother. Again, it's machine learning is a black box. You don't really know what you're gonna get out. Blurring the footage, sometimes tweaking the levels of the brightness to make sure the face has good dynamic range, sometimes has a bit of an effect. And if any of you happen to find a good trick for getting better results out of this thing, like, I don't know, like boosting the shadows, or I have no idea. I would love to hear them, because this whole thing is a little bit magic to me. One thing Nathan pointed out that's really handy is here, if I click on this, then shift-click on the face, I can tab in and select just one vertex, and hit Control-P, and just parent this straight to that vertex. And now it's just parented to that single vertex, and I can think of a bunch of stuff that could be really useful for. Oh, and I should also point out, if you do that with 3 vertices, it'll get a rotation data too, although not scaling. But that's still also just a very handy trick. I don't think I use vertex parenting nearly enough. But let's talk a little bit more about the orthographic aspect, because if we go to the top here, you can see the face is always centered around this x-axis. And even when we cut to a close-up, which we do in a second here, the face doesn't get closer to the camera, it just gets bigger, like that. Here, you can see it's small and big. And that's a little bit weird, and it also means if you're trying to combine this effect with a full 3D track, like, you know, a big complicated thing where you're also tracking the camera and doing all that, you could run into problems, because the face is always going to be just a set distance from the camera. But because Nathan continues to be pretty darn clever, he added an additional functionality to the Python script where you can use perspective mode. And basically what that does is it looks at the points on the side of the head and it goes, okay, let's not scale these up and down. Let's keep those the same, the head the same size the whole time, and instead move it closer and further away from the camera so it matches that same perspective. And he isn't just moving it like closer and further away, he's actually distorting it to like match the focal length. It's really cool. You use it the exact same way, dragging that same script, but this time, because we are trying to match it with, you know, the actual camera, you do have to put in a little bit of information. So I'm going to put -- field of view, and then just whatever number of degrees you see. So, you know, like 45. Or if you happen to know the information, focal, LEN for focal length, and all of this information will be in the documentation too, so you don't have to remember all this right now. You can just copy and paste it in. But I know my camera sensor is 35 millimeters and the focal length is 24. And now with that information in there, it'll automatically give you a perspective output. Also, if you don't happen to know the focal length or something exactly and kind of like put in your best guess, that's a-okay. That's not going to affect the final result. It'll always look absolutely perfect from the camera's point of view. This only affects where it's at, like kind of in depth in the scene, if you're trying to get it to integrate with like other types of tracks and stuff. Let's finish this up. Drag in the video file like normal, and I'm gonna hit space, drag it in again, and I'm gonna change the output to be, have perspective in there just to keep everything straight, and MDD does its thing. And now go back into the zip, and this time we're gonna open up the mesh perspective blend, where we do the exact same thing, load in the footage. There we go, give it more frames, load in the mesh cache, Blade Runner 2 perspective. So the only difference is now we have to select the camera and make sure that these settings match. So the focal length is 24 and the sensor size is already 35mm. And now we just get the exact same result. But now if we go to the top view, you can see the head doesn't scale up and down. It's actually moving in 3D space and actually kind of normalized, which is really handy if you're trying to like add stuff, attach stuff like hats or something to the head. But from the camera's point of view, it all still looks exactly the same. It just can be a little easier to work with. I have run into weird things like when the head turns too much or it's close to the side where you get maybe unexpected results. But again, this is version 1, and yeah. So that's all there is to it, and I'm really excited to see where this technology goes in the future, because it's the stuff like face tracking or automatic, 3D tracking or keying and relighting and stuff like that, where I'm really excited to see what machine learning does. After sitting on the tool for a couple of weeks, I do want to say it's interesting. It totally saved my butt in terms of like being able to create that giant holographic head. It was exactly what I needed.
Yeah. That's funny.
But it's also just so close to being useful for other stuff. Like, oh, I could paint makeup just straight on the person's face and it just tracks straight on there. And it's like, yeah, it can kind of work good enough for that if you're lucky. But like, yeah, and it's just right there for so many things. Like, it's almost good enough to be really, really useful, but it's still kind of in that fudge zone. Okay, let's go to the fudge zone, where you don't totally know what you're gonna get. But I'm still very excited to put this out there. Thank you, Nathan, for making all of this happen. Thank you, Google, for creating these crazy cool machine learned algorithms and releasing them out there to begin with. We'll see what happens. Although also, just gotta say, all props to the Blender Motion Tracker. In the day before Nathan came back and told me he could track everything automatically, I just brute force tracked all of the webcam footage in the Blender Motion Tracker, and I'm just projecting it straight onto like a little base mesh here, but it totally worked, at least good enough for like, for the scene. Just had to throw that out there here because it was a pain in the butt, and took a while, and now nobody will ever see it. Nathan's replacing me with a machine. Look at this sunbeam. You must give up your reliance on oil and join us among the stars.